All right, let's settle this once and for all. Does the Mann-Whitney U Test really compare medians? I know you've probably heard it 100 times in stats class or read it in textbooks. Use the Mann-Whitney U Test to compare medians when your data isn't normal. But is that actually true? Let's break it down step by step. First, what is the Mann-Whitney U Test? It's a non-parametric test. It doesn't assume a normal distribution. That's perfect for messy, real-world data. Use it when you have two independent groups and want to know if they differ. For example, students who drank coffee before an exam, students who didn't. Now here's where things get interesting. The Mann-Whitney U Test doesn't actually compare medians directly. Instead, it looks at ranks of all values pooled together. Imagine lining up scores from lowest to highest, ignoring group labels, then seeing which group has higher ranks. So what is it really testing? What's the probability a random value from Group A is higher than a random value from Group B? If that probability deviates a lot from 0.5, the groups are likely different. Catch: if groups have the same shape and the same spread, just shifted left or right, a median difference shows up in the test. But if groups have different shapes or different spreads, for example, one super spread out and the other tightly packed, the test can detect those differences even with equal medians. So does it compare medians? Not exactly. It compares distributions between two groups. If distributions differ only by central location, it behaves like a median test. If not, it picks up shape and spread too. Rule of thumb: check if distributions look similar except for central tendency. If yes, Mann-Whitney works great. If distributions are wildly different, be careful. The test may mean more than medians. Next time you want to say it compares medians, remember, it's more complicated. Stats isn't always simple. That's the fun part. Thanks for watching and keep those questions coming.